Students, in continuation with elliptical curve crypto system for decryption process. So as I said, we are going to decrypt the message using the formula m equals c2 minus d into c1. So the proof for this particular formula is given as such. Okay, so m is represented as c2 minus d into c1. Okay, so substituting c2 and c1 in this particular equation, we get c2 is what? Your c2 is m plus k into q, right? So your c2 is m plus k into q minus your private key into your c1. So what is your c1? Your c1 is k into p, right? Yeah, so we know our c2 is nothing but m plus k into q, and our c1 is nothing but k into p, right? These two are the received ciphertexts, correct? So the received ciphertext along with the private key, okay, will help to obtain the original message, right? Okay, so now let us solve this particular equation m plus k into q minus d into k into p. Yeah, so you can see here m, okay, plus k into, yeah, so what is this d into p over here? Yeah, so what is our q? Q is nothing but the public key, right? So public key, q is nothing but the public key. So what is q? Yeah, q is d into p. Yeah, so substituting, okay, the public key d into p in the place of q in the equation of decryption process. Yeah, see here, so m plus k and q, so q is nothing but our public key. We are substituting the public key here and it becomes d into p minus your rest of the equation d into k into p, correct? So now we can, when we are solving it, okay, so we can cancel both these k into d into p, cancelling out k into d into p, which will actually be, okay, 0 here, and which will be which will be leaving out the m value alone, which is nothing but our actual original message, correct? Did you understand? Yeah. So m plus k into d into p minus d into k into p. So how did we get this d into p over here? It is nothing but our public key. It is nothing but our public key. Substituting the value of our public key q, okay, which is nothing but d into p, then will be ending with k into d into p minus d into k into p. Okay, so cancelling out these two common terms, will be left out with the value of m, which is nothing but our original message. Okay, and how are we going to map the message, okay, onto the elliptic curve, right? How are we going to map the message onto the selected elliptic curve? I'll be continuing this in the next video.